Right, everyone. We're going to discuss the doubts. I'm going to try to clarify any doubts regarding the one-shot instructions. During this video, we're going to discuss in detail, more detail, the one-shot instructions. So, in order to do so, you're going to have to understand scan time, and basically, that's one of the most important things. If not, if you don't understand scan time, it's going to be kind of hard to go through this. So, try to understand scan time first before proceeding. Okay. So, let's go for this. So there are several one-shot instructions. We're going to start with the simple one. So trailing edge one-shot positive. You can also say one-shot rising. That's a term that is being used a lot. And DOMOR, it's called the trailing edge one-shot on power flow. Actually, leading edge. Let me see. Leading edge one-shot contact, actually. That's the one. Leading edge one-shot contact. That's the one we'll be using for now. We're going to use X0 over here. We're going to use the output instruction here for C0. C0. We're going to use a set instruction here for C1. And we're going to use a Y0 instruction. Before I even proceed, I want to show you how this one works for now on the program. Set PLC, I'm going to connect to the simulator. Okay. Online and view this project. Continue online. Cancel. Right to PLC. And here we go. All status on. So notice that the outputs are off and my input is off, right? So whenever there's a transition from off to on, it's going to turn on my outputs for one scan time. When the next scan time comes in, it's going to check. Same thing. Is there a transition from off to on? If there isn't, it's going to turn off. So look at this. I think my PLC is not in run mode. Perfect. So from off to on. So my set instruction turned on, stays on, because it's a set, right? So whenever this became true at one point, this is going to stay on because I set it there. In fact, if I go to my data view, look at this. C1. It's on, right? Look, I can even delete my code right now. Right to the PLC. C1 still on. Because I had set it there. Okay? It's very important to understand that set and reset instruction, right? Let's revert those changes. It's just a comp setting, so I'm going to have to rewrite the code. X0, C0, set instruction to C1, and then Y0. Notice that C1 was still on. I'm going to write to the PLC. All right, the only way that I can turn that off now, and this is not. Look, it's even off. It's not even a one shot. It's still on. So let's use this one. Now we're gonna go through this. I'm gonna have to turn that off. Okay, I turned it off. I had to force it off. Okay. Okay, so now we're gonna try to explain this in a theoretical standpoint and see, so you guys can see it better. So remember, you have to understand the concept of scan time to proceed. So based on our logic, we have a one-shot rising contact and output called C0. All right, let's check it out. C0, C1. A set C1 and an output coil called Y0. Let's verify that. So now, and this is X0. So notice that this contact right here it's only monitoring whenever a off to on transition happens. Where this is off, this is a 0, and over here is a 1. Okay. During one scan time. It only monitors that during one scan time. So scan time 1, it monitors that. Scan time 2, it monitors that. So if that's not true, this turns off, turns off, turns off, turns off. Notice that once I turn C1 on, it's a set. So it's going to stay on until I make it reset. Okay. So now let's do a little table here. Scan time, scan 1. Last 10 milliseconds. I don't know how much it's going to last, but I put 10 milliseconds. All right. So let's say x0 is equal to 0. It's been equal to 0 all this time. So scan time, the scan of the PLC on the first step, it basically monitors all inputs and creates a data table. Puts them in a table. So in this case, the only input that we have is x0, right? x0 equals 0. All right. Step 2 processes or executes the logic or evaluates the logic. On step 3, updates all inputs, all outputs, I'm sorry. This happens in a period of milliseconds, right? And it happens continuously. All right? So it's happening all the time. So right now, my PLC right now that I have on the simulator, it's scanning continuously, okay? So going back to a little table. So x0 during this period of time, it's 0, right? So the first thing that evaluates on the code was there and off to on transition. So in other words, did this change from off to on during scan time 1? Well, it's been before step 1 or scan 1, x0 was 0, right? And then it's still 0 in scan 1. So no, making this not true, right? So C0 is 0, C1 is 0, Y0 is 0. At sometimes scan 2, x0 turned at another scan time, right? Turned to 1. So you gotta ask yourself the same question. Was there an off to on transition during scan 2? So let's see it. Oh, we were. X0 was 0, right? Now we have a 1. So it went from 0 to 1. From 0 on the table, went from 0 to 1, right? And on the contact, went from 0 to 1. So this right here became true in during scan time 2. So during a 10 millisecond scan, C0 turned on. C1, I'm going to force a 1 there permanently until I reset it. And Y0 turned 1. Exactly, turned to 1. Okay. During scan 3, so notice that I'm turning this on. X0 still is equal to 1. Same question. Was there an off to on transition between this scan, the previous scan, and the scan that is running right now? No, because X0 stayed at 1. If X0 stayed at 1, it went from 1 to 1. This is not 1 to 1. So now, since that is not true, C0 turns off. So it was on for like 10 milliseconds. 10 milliseconds, that's so small. That's a period of time that we cannot even see it on the screen. On the PLC, we can't see it. C1, since it's a set, it keeps being on. It's not being turned on, it just keeps being on from previous scan. Y0 equals to 0, because this is no longer true. Notice that X0 is 1 now. Right? X0 was 1. Now, during scan 4, X0 turned back to 0. So since X0 turns back to 0, it went from on to off. Was there an off to on transition? No. There was an on to off transition, but not an off to on transition. Since that's not true, since this is not true, C0 equals 0. C1 stays at 1 from 2 scans earlier, and Y0 stays at 0. Now, keep going. Scan 5. Scan 5. Now, X0 from scan 5 went to 1. So there's a 0 to 1 transition. Okay? There's a 0 to 1 transition. Okay? Now, was there an off to on transition? Yes. It went from 0 to on. Right? From 0 to 1. So this became true. Now, since that became true, C1 turns to 1. C1 continues being 1 from 3 previous scans, and Y0 turns on. So let's put it here. 1, 1, 1. Actually, and this one stays at 1. Right? No, this one's 0. Okay. Now, what's going to happen? Scan 6 comes along. This is just the next scan time. 10 milliseconds after, what's going to happen? What's going to happen? X1 equals 1. Okay. X0 equals 1. Not X1. X0 equals 1. So there was not an off to on transition. It stayed at 1, right? So since there was not an off to on transition, actually this one stays always at 1. C0 turns back to 0. Y0 turns back to 0. Notice that X0 is 1, but they all turn back to 0 except for the set. So in other words, if you're going to use this instruction to turn something on and leave it on, you got to use something like a set if you want to leave it on. Because this is just going to pull your outputs from on to off real quick. Okay? So C0 equals 0, turns it off. C1 continues being 1 from the set. And Y0 goes to 0 again. Okay? I'm going to prove it to you guys. There's another way of proving it too. There's another timer. We have not discussed it yet, and we probably won't discuss it. You guys want to research on it? You guys can. So we're going to go timer. Let's go. Let's put it right here. And it's called a timer down, global timer. So this timer has a reset. So this timer, even when it turns off, it continues time. It continues timing. I'm sorry. Even when it turns off, the accumulation does not turn back to 0. We will not discuss this timer during this class. If you want to research, you guys can type in that little question mark and you can learn about it. So let me see if I can put it right here. Accumulating timer. And we're going to call this T0. Okay, and the preset value, we're going to put it to 5 seconds. It won't reach there, but that's fine. And reset, we're going to call X3 for now. I'm going to set the changes right to PLC. Multiple blocks require each input leg to independently be tied to left power rail. See what happened there. Yeah. It won't work for me. So let's do something. I'm going to put this one in there. X0. I'm going to put this timer in there. T0 we talked about. And our preset's going to be 5 seconds. Actually, this is not the timer we wanted. We want an accumulating timer. There you go. T0. We want 5 seconds. We will never reach 5 seconds. and x1 to be the preset. So I'm going to show you how long this ROM stays true, basically. Accept edits, write to PLC. It probably won't even show it. It's so fast that it happens. It doesn't even show the accumulation. It happens so fast that this doesn't even register. So that tells me right here that the scan time for this particular program, let me see something. It's at it's more than millisecond range. Might be at the nanosecond range. Well, but the program is really short too, so. So this is so fast, just so you have an understanding. It's not accumulating anything. It's not accumulating anything. Okay, and this timer accumulates anything. Even though it turns off, it keeps accumulating. I can show you right now. We can put a T1 here. So TMRA. If I were to use another instruction, put 5 seconds for the same instruction. So for the normally open contact. Now look at this. You see? Look at it. Okay, look at it right there. So I just reset it with this one, right? Every time I turn on the X1, the reset leg, I reset it instead of turning it off. So look at this. Right now, this didn't accumulate anything. So that tells you something. This is happening so fast you can't even see it on the screen. So going back to our accumulation. So you can see how it turns off. All right. So I guess if you go back here, you notice our set is equal. Let's turn off. The set registers it because it happens really fast. But as soon as you put a 1 into the set, if you any register that is tied to a set turns on, and you don't have to leave it on to stay on, right? It sets it there. Okay. Going back to our simulator. X0, look at it. Bam. C1 stays on. Okay. So now that we understand that, let's do something else. Let's do the other one. C0, C1, Y0. This is an output. This is a set. This is Y0. This is an output. Okay? And this is X0. So this one goes from 0, monitors any transition from 0 to 1, from 0 to 1 in one scan time. After, if that doesn't happen, if a transition does not happen, this is not true. This is not true. Okay? So the question that this instruction asked was there a I put a 0 there. It should be like this, and it should be 1 to 0. Was there a or an on to off transition during one scan time? That's the question you got to ask yourself. Basically, was there did it change state from on to off? That's all you got to ask yourself. If you want to turn on something, when a transition from on to off happens, this is where you use that instruction. Okay? So, going again to our table. X0, C0, C0, C1, and Y0. Scan 1, scan 2, scan 3, keeps going from scan to scan. So initially, X equals 0. In fact, let's put it to 1. X equals 1. So X equals 1. Notice that just because this is 1, X0 equals 1, doesn't mean the instruction is going to permit the power to flow through, right? Remember, start looking at this code like switches on your light bulbs, right? Meaning, when your light switch, when you have a switch, if that becomes on, your light bulb turns true. This is your output, and your switches are your inputs. All right. So you got to start looking at it that way. Okay. So going back to this, X0 equals 1. So if X was there, the question of $1 million, was there an off to on transition during that scan time? Was it? Well, it was 1. Initially, it was 1. X0 was 1. Now it is 1 again during this next scan. So, no, it is not true. So this is not true. This is not true, this is not true, and this is not true. So C0, what's going to do? What's going to be? 0. C1 is going to be 0. Y0 is going to be 0. Okay? Now, all of a sudden, I changed my switch from 1 to 0. So notice that I went from 1 back to low, 0. This symbol means high, or 1, and this is low, meaning 0. Okay? The other one was the other way around, right? So the other one was like this. Low, or 0, to high, meaning 1. Okay? So it went from 1 to 0. So the switch turned off during that scan time. Okay? You know, when it starts recollecting data about it, on its monitor, its inputs, it's saying it changed from 1 to 0. Oh, wait a minute. This is true. This is true. This is yes. So what's going to happen? This one's going to turn on. This one's going to turn on. This is going to be true. So C0 is 1. C1, I'm going to set a 1 there. Now remember, I used to set, so it's always going to stay 1 until I reset it. Y0 turns on. Okay? Now, immediately, this happens 10 milliseconds. In fact, you guys just noticed, This happens in our program. It's so short, the program, it happens in a nanosecond. So probably even shorter than nanoseconds. So it happens really, really, really fast. Now, going back to it. Now it changed back from 0. It stays at 0. Okay. Stays at 0 for now. Was there an on to off? Well, I was off. Now I'm off again. There's no on yet to off transition. So no, there was no on to off transition. So this instruction is not true. This instruction doesn't execute. This doesn't execute. And like I said, this one doesn't execute. So C0 is 0. I use a set, so C1. So I already set a 1 there. It's going to stay at 1. And scan 2 is going to stay out of 0, I'm sorry, because it's an output coil. It's not a set. So in a period of nanoseconds, in less than nanoseconds, this output output C0, C1, and Y0 executed, and you weren't able to physically see it with your eyes. Now in scan 4 happens. Scan 4 happens. Okay, and it's gonna X0 turns from 0 to 1. So was there a on to off transition during one scan time? Well, I was off, now I'm on. No, this did not happen. So this instruction doesn't execute, this instruction doesn't execute, this instruction doesn't execute. So C0 is 0, 1 stays at 1 because this was a set. And Y0 stays at 0. Now let's go to scan 4. At scan 4, all of a sudden you make a transition from on to off. What's going to happen? Well, now it's true. Now C0 is going to be 1. C1 was always 1, so it set again C1, but there was already a 1 there. And Y0 turns on again. So scan 5, oh, this was scan 5. Scan 6 happens. It's going to keep being 0. Right? So was there an on to off transition? No. So this one turns back to off. This continues being a 1 because of the set. This turns back to off. All right, so we discussed 2 of the one-shot instructions. Okay? 2 of the one-shot instruction. Notice that each one of those one-shot instruction, they have in a what we call an address, X0, right? I put an X0 there. Now we're going to discuss a very special one. Very special one. So sometimes, let me delete these. Delete current wrong. I'll delete these as well. Delete current wrong. Okay? Sometimes you have a bunch of inputs here. And you can leave just one there. You can just put one that you're thinking about, right? You're thinking about. So let's say you have X0, but you wanted this. And you really don't care about when those conditions are going to happen between off and on. You just want to know that when the entire wrong goes from off to on. Okay, so let's put an X1 here. X1, yes, X1. Okay, and then you're going to go to your contacts, and you're going to see this one, leading edge power flow. Notice that this one doesn't have any address. Doesn't occupy any memory either. Okay? Address, it doesn't consume memory addresses. It's just saying, hey, when this logic here, when it gets evaluated, and it goes from off to on, then execute this for one scan time. Then when it comes back, it's going to turn them off. It's not going to execute anymore unless there was an off to on transition. Okay, so let's accept. It's almost basically the same, right? So let's turn off C0. or C1. So I turn on. So in order to be true, this have to be true between being off to true. So X0 is on, then X1 is on. Bam! When I turn them off, notice that I can leave them on, and these instructions do not execute. Now, if there's an off to on transition, like right now there was an off to on transition, it executes this, but really, really fast during one scan time. So let's discuss about this one, the leading edge one-shot power flow. Again, if you have doubts about instruction, you can go here. And I believe there's a instruction help. There you go. It tells you everything. The ladder logic below shows where the leading edge power flow modifier contact is allowed. Know that it's not allowed. Notice this. This is not allowed between. It tells you everything. It's not allowed to use a branch like this and put this in the branch. Right there, if you want to have that, you use the one that we discussed, the one-shot rising, that from off to on transition, it turns on. Okay. When power flow through all the contacts X0, X1, X2 transitions from off to on, output Y0 will be on for one complete scan time. Not more than one scan time. It's the same for every one of the other instructions. It won't be more than one scan time. Unless, not even that. It won't be on for the, it won't execute that output. That's why I put the set instruction there to leave it on. Okay. Let's go back to our board. Let's explain this real quick. We want to use the same analogy. So now you have this. X0, X1, then you have your little one shot right here. From 0 to 1, and you got your C0, C1, Y0. Out, set, out. Okay? Now let's start analyzing this. So now, scan 1, scan 2, scan 3, scan 4, scan 5, scan 6. X0, and this is, I want to use this instead, right? X0 and X1, then C0, C1, and Y0. Okay, X0 and X1. So let's say X0 and X1 initially was 0, meaning, what are the conditions? So X1, X2, X1 and X2. So 0, 1, 0, 1, 0, 0, 1, 1. So 0 and 0 is 0. 0 and 1, let's look at it. So this one is 0. All right, x1 is 0. x1 is 0. And look at this. x0, x1. So x0 is 0, x1 is 1. So this one, nope, doesn't pass, and this one passes. But since this one doesn't pass, it doesn't really matter. So it's 0. 1, 0, the same thing. Now this one passes. No, I'm sorry. This one passes, but this one doesn't. So it's 0. And when it's 1 and 1, so basically just imagine switches, right? Little switches. x0, x1, turn my light bulb. So in order for my light bulb to be on, both of them have to be on. So both of them have to be on. Okay. You can give it pause if you want to see that again, or there you go. They both have to be on. So basically, on. Oh. Both of them have to be on. Let's put it like that. On. Alright. So basically, both of them have to be on. So in scan 1, both of them were on. Were one, I mean, both of them, one of them was off, or both of them were off, so it was 0. Doesn't really matter. C0 becomes, it still would be 0. Oh my God. C1 will be 0. And then I got Y0, which will be 0. All of a sudden, X0 and X1 become 1. 1, meaning on. So now in scan 2, X0 and X1 becomes 1. So this logic, the combination of this logic, went from 0 to on. So what this is evaluating is, did the run go from off to on during one scan time? So that is the question. That's what you got to ask yourself. So did it went from off to 1? Well, X0 and X1 did. So it went to 1. So now C0, so this is 1. C0 is 1. C1 is a set, so I just set a 1 there, and Y0 turns 1. This happens in nanoseconds, it seems. Actually, this whole thing will happen in nanoseconds, probably. Okay. Now, the same thing. All right. So now, let's say X0 and X1 went from 1 to 1, stayed on. So the question, did the entire wrong go from off to on? No, the entire wrong went from 1 to 1. So this not true. This did not execute, doesn't execute, this doesn't execute. So C0 goes to 0. C1 is a set, right? So if it was a 1, it's going to be continue being a 1 unless there's a reset in my program that resets it. We don't have a reset right now, so it stays at 1. Y0 doesn't execute, so it goes back to 0. Now let's say my entire rung becomes false. Goes from on to off. From on to off. This one is monitoring something else. Did the rung, this entire rung behind it, go from off to on during one scan time? No, it did not. So the same thing, doesn't execute, doesn't execute, doesn't execute. C0 turns back to 0. The C1 stays at 1 because there's no reset. And Y0 turns to 0. It continues being 0. Now all of a sudden, my entire rung goes true. The question, did the rung go from off to on? From off to on. This is the symbol off to on is right there. From off to on during one scan time? Yes. So C0 turns on, C1 stays on, and Y0 turns on. Now in scan 6, the rung continues being true. Right? So did the rung go from off to on during one scan time? Did the rung go from off to on during one scan time? Well, it went from on to on. It didn't go from off to on. So no. So this instruction doesn't execute, this doesn't execute, doesn't execute. So this one becomes 0, actually not 0, stays at 1, and this one goes back to 0. So notice that I go from, in most of the cases, I go from 0 to 1, then going back to 0. This phenomenon is that it turns off so fast that we don't see it. And then it goes back to 0, then it turns on, but this happens so fast that you can't see it with your eye. Not even with a slow motion camera. Okay? Now, as you can see, we completed these. We completed that. So notice that you use this instruction to monitor transitions. You don't use to monitor a run. It doesn't make the logic run faster. None of that. Because it's still going to evaluate the logic. It's still going to look at the logic if there was an off to on transition. So I'm going to show you an example that you can use this. So on the project, we have something like this, x3, x4, and then we have a move. And I'm going to put a, so we're going to move step 1. This is going to be V1. Okay. Then we might have something like this. Something like when V1 equals 0, C1 is true, then C3 is true. Right? I'm going to eliminate the logic upstairs. This logic, I'm going to eliminate it. Delete wrong, yes. And then it says, well, that's fine. So now when C3 is off, meaning this no longer executes, so when C3 is off, I want to move to step 2, for example. Look what's going to happen. So right now, I'm going to put x3 and x4, x3 and x4, bam. So it didn't even let this one execute. Let's put it off here. Look at this. Let's put a V1 here, V1, and let's put a 0 here. It's not even letting it. Right now, if you guys notice, I am forcing a 0 to V1. Okay? Let's put C3 to off. Actually, to on. C3 to on. Let's force it in there. Force off. Force on. Right now, it is confusing, I know. So I put a 0 there. Let's unforce it now. It doesn't know where to go. Okay? So if I put a 1 there, it doesn't grab the 1 because the program's so confused. It doesn't know what to do. Now look at this. Because it's moving a 1 there, but it's also moving a 2 and it keeps going on a loop. And a really fast loop. So look at this. So let's do this. You're going to see the change in behavior. I'm putting a 1 in there. C3 doesn't want to turn on. Force element change value. I'll write it to the PLC. Force element to on. Alright. I don't know what's wrong with C3 right now. It's acting all weird on me. I don't know if it has something to do with what I wrote before. Maybe it has some other runs that I'm not seeing. 1, run 2, run 3. Let's see if I don't have any subroutines. Nope. Okay. So if I unforce it, it's off. If I turn it on, it stays like that. Well, let's write another one then. C1. Oh, I know why. Because this was used as an output. I see what happened. So let me delete this so you guys can see it. It's good that you guys see that so you guys can understand other issues that can happen during the program. Remember, I'm preparing all this out of nowhere, right? To show you the concept, right? So right now it's at step 1. It's at step 2, right? So if I put C1 back to on, bam. Okay. Then notice that this instruction, even after it becomes true, it already moves at 1, right? So when I'm in step 1, actually this should be step 1. Okay. And C1 is not true. This is like, you probably want to have this like this, V1 equals to 1. When you're step 1 and this executes, you want to move step 2 to V1. So if you read the code at it, if you try just reading the code through, right, saying, well, you're in step 1, this happens, right? Now when you're step 1, once C1 becomes not true, you move to step 2. But at the same time, you're moving step 1. So the logic kind of doesn't make sense because you're moving to step 1 because this is true, right? So let's say this is true, which is going to happen to you in the project. X3 and X3 and X4, X3 and X4. So X1 is true. You are in step 1 now, right? You were in step 1 before, but just because that happened. Usually this might continue to be on. So in order to, like, for that not to happen, so let's say you have two limit switches that make you to be on. So you're in step 1. Now to move to step 2, yeah, let's see what happens. So I put an off. You move to step 2. But at the same time, you're actually moving. This is true, so you're actually moving to step 1. So once you start moving more steps, let's say V1, basically, once you start moving more steps, this becomes a mess or program. So right now it's saying I'm in step 2. That's good because this one, it cancels out, right? You're in step 1, and now you're in step 2, but it will become tedious. So what you do is, notice that this doesn't have to be on all the time. So you put this in front of it, bam. And then you put this one in front of it, bam. Now what's going to happen is, right, so let's put V1 at 0. So V1 is 0, right? When there's a transition from off to on, notice that before, just now, these two were on, and this one continued to be 0. So I have to transition them from off to on. So just by making one of them doesn't make it true. Don't make it 1. Doesn't make this true. So when I make this one true, it moves to step. Didn't even let me to move to step 1. Right? So let's try it one more time. Happened so fast because this one was it's not on. So like right now, those two are on, right? That's a good example. So now C3 is on because you're in step 1, stays on, right? To move to step 2, C1 needs to be off. I move to step 2. Notice that it no longer needs to stay on to maintain this value in there. So that's how that instruction works. Right? It's very useful for this type of I'm not forcing into you using it. You can do it without it. I just recommend it before when you use a move instruction. If nothing else is moving anything to it, and you're not expecting for that to happen, you should use it. It could be utilized in a good way so the program sequences the way that you want it to sequence. You don't want to say, I'm in step 2 and now I'm going to move to step 1, but it's still moving step 2. And once it's moved to step 2, then it kind of forces the value in there, even though I was still moving a 1. It kind of makes no sense. All right. All right. I hope this helped.